idle spring seat washer, idle screw retention spring, idle speed adjusting screw, governor shims. In the governor, the flyweights are driven through gears by the fuel pump main shaft. The governor plunger is held between the flyweight feet and rotates with the flyweights. Any rotation creates a tendency for the flyweights to move away from their axis of rotation, which is the center line of the weight carrier shaft. This outward push is known as centrifugal force. The rotating flyweights pivot on the flyweight pins. Through this pivoting action, an axial force is exerted on the governor plunger through the flyweight feet. At any given speed, the position of the governor plunger is determined by the balance between the flyweight force exerted on one end of the governor plunger and the spring force applied to the opposite end of the plunger. The position of the governor plunger is determined by the balance between the flyweight force exerted on one end of the governor plunger and the spring force applied to the opposite end of the plunger. Torque is dependent upon the quantity of fuel that is metered and injected per cycle. In the PT fuel system, at any given speed, torque is dependent on rail pressure. The control of rail pressure in the PT fuel system begins by regulating the fuel pressure supplied to the governor assembly, appropriately called supply pressure. The control of this supply pressure is accomplished through the use of a bypass type pressure regulator. This type of pressure regulator is designed to unseat when a designated supply pressure is reached. For this type of regulator to function, an excess supply of fuel must be delivered to the governor assembly. This ensures that during fuel pump operation, some fuel is always being bypassed, enabling the regulator to maintain control of the supply pressure. When the fuel pressure exerted on the button exceeds the force holding the button and plunger together, the button is unseated and fuel is bypassed to the suction side of the gear pump. The pressure at which the button separates from the governor plunger is determined by dividing the spring force acting on the button by the recessed area of the button. The recessed area or counter bore is the specific area the fuel is pushing against. For a given spring force acting on the button, increasing the recessed area reduces the pressure at which the fuel begins bypassing, thereby lowering the supply pressure. Decreasing the recessed area will have the opposite effect, that is, fuel will begin bypassing at a higher pressure, raising the supply pressure. Changing the recessed area of the button will change the height of the supply pressure curve. A button of a smaller recessed area will raise the supply pressure curve. while a button with a larger recessed area will lower the supply pressure curve. Also, with a given recessed area, any change in plunger position will change the force on the button and change the supply pressure. Increasing speed changes the plunger's position, increasing the force on the button, which raises the supply pressure. It is important to understand that there is a unique supply pressure for each speed. Supply pressure is independent of the flow out of the pump. The regulation of the supply pressure is the first step in controlling the rail pressure. The automotive governor controls idle governed speed and maximum speed by positioning the governor plunger cutoff shoulder over the appropriate fuel passage. Around idle speed, flyweight force is opposed